Our experiment is on how salinity affects thermohaline circulations.
Thermohaline is a part of a large-scale ocean circulation that is driven by global density gradients created by surface heat and freshwater fluxes.
Ocean currents arise in many different ways. For example, wind pushes the water along the surface to form wind-driven currents. Deep ocean currents are caused by the differences in water temperature and salinity. In this experiment, we will develop a model to explain the role of salinity and density in deep ocean currents.
The materials are 4 mason jars, salt, tablespoon, a stirring stick, an index card inside of a plastic bag, food dye, blue and red, 6 cups of water, and an extra mixing cup. First, you're going to pour 2 cups of water into the mason jar. And then another 2 cups in the other one. And you're going to add 2 tablespoons of salt. Then add 3 drops of blue food coloring and stir the solution.
As you're stirring the solution for the salt water, add 6 drops of red food coloring to your fresh water.
And then you're going to take the blue solution, pour it into the extra cup to get rid of the excess salt. And then you're going to pour it back in. Add 3 more drops of blue food coloring and stir. Then you're gonna take the index card and place it over the blue, line it up with the red, and you're going to flip the blue solution over onto the red. Okay, 1, 2, 3. And you're going to slowly pull out the index card. And observe.
Since your salt water is the one that was on top and your fresh water was the one that's on bottom, since the salt is more dense, it'll sink down and they'll mix and your experiment will turn purple. Next, you will do the same exact process all over again, just repeat it. But this time you'll have your salt water solution on the bottom and your freshwater solution will be flipped onto the top.
So place the index card again. Ready, 1, 2, 3. Okay. Go ahead.
This time, the colors won't be mixing and the top will stay red with your freshwater solution and the bottom will remain blue with your saltwater solution. This is due to your salt water being the more dense of the two because of the salt in it and the salinity.
In Earth's equatorial regions, surface ocean water becomes saltier as the water, but not the salt, evaporates. However, the water is still warm enough to keep it from sinking. Water that flows towards the poles begin to cool. In a few regions, especially in the North Atlantic, cold, salty water can sink to the seafloor. It travels in deep ocean back towards the equatorial regions and rises to replace water which is moving away at the surface. The whole cycle is very important in regulating climate as it transports heat from the equatorial regions to polar regions of Earth. The full cycle can take thousands of years to complete.